Now that you've learned about determinants and how they work, you're ready to move on to Cramer's rule. Cramer's rule is used to solve a system of linear equations, named after, apparently, the Swiss mathematician Gabriel Cramer. So here's what he does in order to solve a system using his own rule. When you're given a linear system of two variables, remember that A, B, C, and D are just numbers. They're coefficients of your variables. And so what you do with these numbers that are in those positions is create your coefficient matrix. So over here you will notice A, B, C, D in the same positions as they were there. Okay, so let's look at what Cramer's rule says. Here is Cramer's rule. It looks scary. Don't be scared. I'll explain it to you. Notice this says x equals, and this one says y equals. And once we follow the steps in the rule, out pop your x and y values, and it's quite straightforward. So here, let's dig it apart. In both of these denominators for x and y is your determinant of your coefficient matrix, and you know how to find that. Let's look closer at the numerators. It's telling you to find the determinant of these numbers inside here. E and F, notice, are in column 1, which is the x column of your original system. So what you do is you take your constants E and F and you replace what was in your x column with E and F, the constants. B and D are really just the coefficients of your y variables. Then you take that determinant, divide it by the determinant of your original coefficient matrix, and out pops the x value. Over here, y. Notice your y column is now replaced with the constants E and F, and A and C are your x value coefficients from the original system. Let's get started with an example. Here we have a system that we need to solve for x and y, but I think it's important to note this note on the side, that there's no reason you couldn't solve this system using substitution or the elimination method. Remember, this is really our fourth method for solving a system, but it's a nice way to check yourself if you're unsure that you've used Cramer's rule correctly. So our first step is to evaluate the determinant of the coefficient matrix. Well, we need to write that first. So our coefficient matrix, remember, is made up of the coefficient of our x and y values. So 9 and 3 go in the first column, and 4 and a negative 5 go in the second column. And now I'm going to evaluate the determinant, so I'm just going to write the determinant symbol so we know we're taking and finding the determinant of those numbers. So remember, the determinant means you multiply these numbers together, the diagonals, and you subtract their products. So you're going to take 9 times a negative 5, and you come up with negative 45 minus the product of the other diagonal, which is 3 times 4, and that is 12. And put that together, and you will get a negative 57. So you've already found the bottom number of your fraction for Cramer's rule. And I'm going to set these up, and you know it's x equals and y equals, and it says the determinant of A goes on the bottom. Alright, well, let's start with x. Remember, for x, when we're looking for that determinant matrix, what we're going to do is replace our x column or x coefficients with the constants. So you're going to put that negative 6 and negative 21 in your first column. So there's a negative 6 and a negative 21. In your second column, just go the numbers that were in your coefficient matrix, which would be 4 and a negative 5. Alright, so just notice that one difference. And now I need to find the determinant of the numerator. And we're going to multiply negative 6 times a negative 5 and get 30. And subtract from it negative 21 times 4, which is a negative 84. And that still is over negative 57. Alright, well, this cleans itself up there. And then I will rewrite that I have x equals, I have negative 57 on the bottom, and then when I take 84 plus 30, I'm going to get 114. And then that actually is divisible, and your x turns out to be a negative 2. Alright, let's go over to the y value, and we will take the determinant of your x column numbers, which were 9 and 3, and your y in this case gets replaced, remember, with the coefficient matrix -6 and -21, and we will take the determinant of that. So 9 times a -21 is a -189, and we will subtract from that a -18, and then we get really the addition statement there, which is -171 over -57, and that reduces to 3. So y equals 3. So is this true? Now you can always check. These are one of that fabulous situation where you can substitute those numbers in and find out if you were correct. So let's do that this time around. And I'll just say check, and we had 9 times the -2 plus 4 times 3, which is -18 plus 12, which is indeed a -6. And then the second equation, we had 3 times the -2, minus 5 times 3, and you get your -6 minus 15, which indeed is -21. So there's no reason you should get these wrong. And we'll practice some more. Now I jumped right to the guided practice to continue doing the 2x2 Cramer's rule before we move on to the 3x3. That one's a little more complicated. I will walk through number 5 with you and then give you the answer to number 6 if you felt like you needed more practice. So looking at number 5, remember our job is to write your coefficient matrix 3, 2, -4, and 5, and then take the determinant of that. So that would be 3, 3, 2, -4, and 5, which tells us to do 3 times 5 is 15 minus a -8, and then you add those and get 23. So our determinant in the denominator of our x and y fractions will be 23. All right, now we need to write our numerators. We are taking the determinant of the replaced values here for our x column, which would be -15 and 13, and our y values stay, which is -4 and 5. And then we need to take the determinant of that, which turns out to be a -23 over 23. So immediately you know x is a -1. Over in the y numerator, we are taking the determinant of our x column numbers 3 and 2, replacing our y values with the coefficients, or the constants, which are -15 and 13. And let's take the determinant of that, and that is a 69 over 23. And when you reduce that, you end up with 3. Remember, you can check those numbers and plug them back in. You could get 3 times a -1 minus 4 times 3, which is a -3 minus 12, -15, which is what we had, and 2 times a -1 plus 5 times 3, -2 plus 15 is 13. So you can be assured that those two are right. Now you go ahead and do number 6 and pause the video if you like. I will tell you the answer when you come back. Alright, the answer for number 6 is, and I'll just put it up here, 4 and a -2 are your x and y values for number 6. Alright, let's look at Cramer's rule for a 3x3 system. Here I have a linear system, 3 variables and 3 unknowns. Notice the coefficient matrix is set up sort of the same way, except now you have coefficients of 3 variables. So here is my my x column of coefficients, here is my y column of coefficients, and here is my z column of coefficients. And then when you jump down to Cramer's rule for x, y, and z, you will see again that the determinants of a are in the denominator, and that we're going to take the determinants in the numerator, except now your x column again is replaced by the constants j, k, and l. but your Y coefficients and your Z coefficients remain the same. When we're looking for Y, our Y column is replaced with the coefficients J, K, and L, and our X coefficients and Z coefficients are in those rows. For Z, we replace our Z column of coefficients with the constants, and our X column and Y column of coefficients is substituted in. So we'll start with an example, and it's a chemistry example using atomic weights of certain compounds. So here's the three compounds. I have glucose, carbon dioxide, and hydrogen peroxide. We need to set up our system of equations, and we do that based off the formulas for these compounds, but don't worry, you won't be tested on this. I just think it's kind of a neat problem. So for glucose, you can see that it is made up of 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms, which gives us a system of equations 6C plus 12H plus 6 oxygen, and I'll make my O like that, and that atomic weight is 180. So there's your first equation. Your second equation comes from carbon dioxide. You have 1 carbon, you don't have any hydrogen, I'll put a line through that O, and then you have 2 oxygen, and that atomic weight is 44. You have no carbon atoms for hydrogen peroxide, but you do have 2 hydrogen, and you have 2 oxygen, and that atomic weight is 34. And don't worry, you won't be tested on that part, but it makes a system of 3 equations and 3 unknowns. And so we will start by finding the determinant of that matrix. Now this is a 3 by 3. I'm going to actually do the determinant up top here because I'm going to run out of room. So I set up my coefficient matrix, which will have the numbers 6, 1, 0, 12, 0, 2, and 6, 2, 2. Those are all coming from these coefficients of C, H, and O. And remember, this is a 3 by 3 now, so I need to add that extra rows, the extra 2 rows, 6, 1, 0, 12, 0, 2. So now we take the products of the diagonals, and then we will subtract them. So let's start with, I'll change my color to 6 times 0 times 2, which is just 0, plus 12 times 2 times 0, which is 0, and 6 times 1 times 2, which is 12, minus, and I'll change the color to green, and then we take these diagonals, we take 0 times 0 times 6, which is 0, 2 times 2 times 6, which is 24, and 2 times 1 times 12, which is 24. I apologize, this is quite squishy. So now I gotta I'll do an arrow. Nothing an arrow can't solve. Okay, so the determinant of that matrix, which I guess we'll just call A because it makes sense according to our formula, will be 12 minus 48, so it's a negative 36. And that's important, so so we don't lose it. Determinant of A is negative 36. So now, looking back up here, I'm going to set up my determinant for X, and I will, I guess, do, well, a purple. These decisions. So my X value will come from the denominator being the determinant of negative 36. And I'm going to leave myself room up top to write all those numbers. So my first column for X, remember, gets replaced with the coefficient in my equations, my 3 equations. So my first column will be really the 180, 44, and 34. And so I'll just write that in a different color so it sticks out for you. 180, 44, and 34. And then our Y columns stay the same. That would be 12, 0, and 2. And our Z column, which is our O's, in this case our oxygens, are 6, 2, and 2. And I need to find the determinant of that. So when you take all of your numbers, you were going to take your 180 times 0 times 2, which is just 0, remember you have to add your two columns, which would be 180, 44, and 34, and 12, 0, and 2. And then you're going to take 12 times 2 times 34 plus 6 times 44 times 2. And from that, you are going to subtract the other diagonals, 34 times 0 times 6, 2 times 2 times 180, and 2 times 44 times 12. And for the sake of time, I will just tell you, you end up with negative 432 in the numerator and negative 36 in the denominator. And when you divide, you get 12. So your X value, or in this case, it's really your C value, your carbon, is 12. And actually, it's really our C value, so I should change this to a C. I apologize. All right, let's move on to H, and we'll find our value for H. And we will just write up here that H equals, and we know our determinant in the denominator is a negative 36. In our numerator, we write our C values in the first column, which is 6, 1, and 0. We are replacing our second column values, our H values, with the coefficients, or sorry, the constants, 180, 44, and 34. And then our final column are just the numbers for oxygen, 6, 2, and 2. And again, it's a 3 by 3, so I need to add that third column. Here's 180, 44, and 34. And when you go through and find the determinant of that, you will end up getting, and do try this on your own, a negative 36 in the numerator for that determinant, and you have that negative 36 for the determinant of the original matrix A, and so your hydrogen turns out to be 1. And remember, we're finding the atomic weights of each of these separately. So carbon was 12 and hydrogen was 1, which perhaps you might already know from chemistry class. Finally, we need to find our oxygen atomic weight. I will do that up here. Oxygen, and we know our determinant in the denominator is a negative 36. And setting up our numerator, we keep our carbon numbers of 610. You keep your hydrogen numbers of 1202, and now we are placing our oxygen numbers with the constants 180, 44, and 34, and adding on our second two columns, which is 610, 1202. And then when you go ahead and find the determinant of that top number, you end up with a negative 576 over negative 36, which turns out to be 16. And then now you have your answer for your atomic weights for all three of these atoms. First you have your carbon, which is 12, your hydrogen, which is 1, and your oxygen, which is 16. And there is your coordinate triple, which is your answer. All right, so let's do one more problem. You can do it with me, or you can go ahead and do it yourself. We're going to do the guided practice number 7 that we had ignored before, and I'm going to clear this up, and we will either, you can walk through it with me slowly together, or you can work ahead of me and skip to the end of the video to find the final answer. So we have number 7 here, and I need to write a coefficient matrix, or a coefficient matrix, and I would get 3, 4, 2, negative 4, 1, negative 3, 2, negative 5, and 1. And I need to find the determinant of that. So in order to not rewrite that like I like to do, I'm just going to erase the matrix brackets and throw in my bars, which tells us that we're going to find that determinant. Remember, you need to add the next two columns so we can actually find the determinant. And so you go ahead and try to calculate that determinant. Remember, you're taking these diagonals and multiplying them and subtracting then these diagonals from it. So pause it now and go ahead and find that determinant. And hopefully you saw that it was a negative 14 for that determinant. Now we can start finding our x values and y values and z values. So I know I have negative 14 in the denominator. And in my numerator, I will be finding the determinant, and this is where we replace our x column with that with the constants 18, negative 13, and 11. So I will write those down first, 18, negative 13, and 11. My y values stay the same at negative 4, 1, and negative 3, 2, negative 5, and 1. And then you add the additional 2 columns on. Oops, and that is positive. Watch, any little mistake can be a pain. All right, now find the determinant of the top and come back and see if we match up. So pause the video now and find that determinant and see what your final answer is for x with me. Okay, so for the determinant in the numerator, I got a negative 28, and in the denominator, I got a negative 14, which then reduces to an x value of 2. I'll walk through y with you. We know we have a negative 14 in the denominator, and this time we write down our x column 3, 4, 2. Replace our y column with the constants 18, negative 13, and 11. And our z column has 2, negative 5, and 1. And then rewrite down the final 2 columns, 3, 4, 2, 18, negative 13, and 11. And I will pause the video and find the determinant. You do the same thing as well. Okay, well, for my numerator, I got a 14, and my determinant of a in the denominator is a negative 14, and so y is a negative 1. Moving on, we will try to find z, and I will do that over here to give myself space. It's so squishy. So I will get z equals, and I write down my coefficients for x and y, which are 3, 4, 2, negative 4, 1, negative 3, and z is replaced with the constants 18, negative 13, and 11, and write down 2 new rows or columns, 3, 4, 2, negative 4, 1, negative 3, and now we are back to where we were for the other ones. You find the determinant for the numerator and come back and check. Alright, well, I got a negative 56 for that numerator, and put my negative 14 in the denominator again, and then when you divide, you end up with 4. So in this problem here of my 3 variables and 3 equations and 3 unknowns, I have an answer of 2, negative 1, and 4 as my coordinate triple for values of x, y, and z. And always, as always, you can check those to make sure you are correct. Thanks for watching my video. Remember, practice will help you. Remember how to do these things, and good luck.